Assalamu alaikum students. It's our 12th lab of OOP and Data Structures lab. The title of the lab is queue implementation with using linked list. In this I will implement the queue in C++, but we will use the linked list method. We will create node for queue for insert that the node that we are inserting and deleting. So we will use the node, how we implement it in the linked list, and in the same case we will implement it in the queue, but the insertion and deletion points are different of queue. So in this lab I will tell you that from which end we will insert the node and from which end we will delete the node. So this here it is our previous labs which we have already done in the OOP and data structures lab. Some of the labs covered the OOP topic, while the remaining labs cover the data structures. So coming to our lab number 12 is the queue implementation using linked list. So in this lab the main objective is to familiarize students with queue implementation using linked list. So in this lab I will tell you about the queue, its implementation, its definition, and that how you implement it using the linked list. So the part that I will implement in the C++ program are following: that we will create a node for the queue, then we will create the functions for enqueue and dequeue. For insertion in queue we will call it enqueue, while the deletion of node in queue we will call it dequeue. So enqueue for insertion and dequeue for deletion. And we will also create a function for displaying that what are the nodes. First the queue will be empty, then we will enqueue or insert some elements or nodes in the queue, then we will display the data, and then we will delete some nodes. So then we will display the data and we will compare that at which end it is inserting or deleting the nodes. So it will insert and delete according to the definition of the queue. So what is queue? Queue is a linear data structure into which items can only be inserted at one end and removed from the other end. So if you are comparing the queue with the linked list or the stack, so you can say that it is that type of data structures in which we will insert node to one end and remove the nodes from the other end. So the common example of the queue is everywhere. If you are making a row, so the first person in the row will be served first, mean first come first served. So a queue is a FIFO, first in first out structure, mean the first node will be delete first. The objective of the queue is to serve data in their arrival order. So the way it will be give it a priority, that the node first arrived will be entertained first or delete first. The first coming process is served first, mean if you are processing if you are doing any processing on, so the first coming process is served first. The process who come first wait at the start, followed by the process coming after, and so on. The side through which data is inserted is called as backend or rear, and process is known as enqueue. So the insertion process is called InQ, and the side at which the data is inserted is back end. The deletion side is known as front end, and the process is called in terms of Q as DQ. So the insertions we will call in Q is in Q, while the deletion is called at DQ, and the sides at which we are inserting is the back end, mean we are inserting something at the back while removing from the front. It is just like a row waiting for something, for a bus or for buying a tickets, or anything you can, if there is a row. So a new person will come and will stand at the end, while if we are removing or entertaining any person, so the front person will be entertaining and then he will be removed from that row. So that's why insertion at the end while deletion from the front. So that's why we called that the data is inserted at the back end while deleted from the front end. So some of the operations in the queue, these are the operations which are implemented for the queue, that the insertion is in queue, while the DQ is used for the deletion or removing the nodes. So in queue, place X at the rear of the queue, at the end of the queue, and queue, and rear. DQ remove the front element and return it. So front should be known, that which is the front, because we have to remove it. And then the operation is empty, return true if q is empty, false otherwise. Because whenever we were implementing the linked list or the stack, we were when we were inserting something, so we will check it either it is empty or not. If anything is empty, that you can insert anything, but if anything is full, then you can't insert anything in the data. And then for removing, you will also check that either the queue is empty or not. If it is full, then you can remove things, but it is empty, then you can't remove things. So the empty and full will be checked. And this is diagrammatically I will show you that how you can insert. It is the implementation of the queue. The process can be simple, demonstrated as follows. So this is the process of queue. Here we have 4 elements, and as we are implementing it through the linked list, so we will write it just like nodes. So this is the front and this is the back. So one is the front while this is the back. So if anything in it's inserting, if we are in this case, if we are inserting any new thing, so it will come after 2. But if we are removing anything, so the front will be removed. The above figure shows queue elements on the left with 2 pointers, front and rear. Mean you have to mention 2 pointers. The one will be pointing the first, while mean the last, and the second pointer mean if you are inserting anything, so it will be at the rear side. And if you are removing anything, so the front pointer will be responsible for it. So this is an abstract view of the queue independent of its implementation method of array or linked list. On the right side is the same queue using linked list and pointers of front and rear. So the front will be these 2 pointers will be responsible for any element which is recently inserted, or which element we want to delete. When dequeue function is called once, mean deletion, the front element 1 is removed. The picture of the queue showing one element removed is also repeated. So I will show you the figure. Here I have removed, as the front will be the first it was on 1. So if you call the function of dequeue, so 1 is removed because the front pointer is at 1. So the front is, and now the front pointing is pointing the second node. Now at this stage of the queue, call in queue, if we are inserting any element, so the rear will be changed. To insert an element 9 and 8, the following figure that the new element is inserted at the rear end and rear pointer starts pointing this new node. So the new new queue will be just like this, that if you are inserting anything, so the rear pointer will pointing it, and if you are inserting anything, if you are removing anything, so the front pointer will be pointing it, and if I want to add something, so the rear pointer will be pointing to it, just like this. First it was pointing to the 2, but as we insert the 9, so now it is inserted the, so we have to change the position of these pointers. We have to assign for the rear pointer will be for insertion a new node, while the front pointer will be used for deletion. Mean we will change it. If now I will call the function of deletion, so the front pointer will be then pointing to 5. Now coming towards its implementation in the C++, here I have write a code for queue. First we will create a node for queue, just we have created for the linked list and the stack. I have mentioned the headers here, iostream, and the using namespace sdt. Then I have create a class node underscore queue, node for queue. If you check, so all the node code is same for the linked list and also for the stack, so you can use the same node code for all three. So in this I have create a data, as we are as we have already know that a node have a data and a pointer next, and publicly we have assigned the data a in a function. In a constructor we have assigned a data a to data, and then we have assigned the next node to null, as we are creating the nodes. So the if we are creating a nodes and this is the first node, so the next node will be null. Then we will make a function for setting a data, so this data is equal to data. If you are using this pointer and you write this symbol, so a number of functions will be uh, listed in front of you, then you can select the items from there. Then we have get data. First we will the set data, so the pointer, the data will be assigned to data, and then we will have a get data function, so it will return us the data. Then for pointers, so the first we will assign the set next function set next, and we will create a next pointer, and we will assign the next node pointer to that next pointer, and then the next get next pointer. So in this function we will return that pointer. So this was our code for the node for the queue. Now coming towards the main code of the queue, so as I have write a node underscore queue, so you will save that file with the node with the same name as of the class .cpp, and you have to just include it in the other cpp file. So like this you can include cpp files. Mean if you are you have create only one node file, then you can call it in by implementing the queue, stakes and linked list, because all the node codes will be same. Now coming towards the queue, I have created a class queue, and in this I have privately declared a data, as we will have a data in the queue. And as in the diagram I have shown you that we have two pointers, the front end pointers and the back end pointers. The front end will be used if you are deleting anything, and the back end if you are inserting anything. So then I have a constructor queue in which I have assigned data 0, front end 0 and back end 0, that we have nothing in the queue. We are creating a new queue from the start. So for this you have to insert the nodes. So I have, this is a function for insertion in which the variable m is passed. So this is the node node underscore queue. This is the method of how to you create a new node. So this is I am creating a new node node underscore queue. So for new node, then you have to assign the set data and then the set next pointer. This is for creating a new node, and then you have to assign data to the new node, and also the set next pointer to the new node, which is initially null. So if backend, for insertion you will use the back end pointer. If back end is not equal to null, if back end is not equal to null, so back end should be assigned to the new node, else front end new node. If back end is not equal to null, if back end is not equal, okay, this is that backend is not null, so the backend will be assigned to the next pointer of the new node, the first node that we are creating, else the front end new node. If we are inserting any queue in the node, and there is only one node, so the front end will be that node, and the back end will be assigned a next, because if we are inserting any new thing, so it will be assigned to it. So the front end and the new end will be assigned the front end and the back end, because we have only one node. But if you have only one node, and then you are inserting if this function is inserting for the second time, so then the pointers will be then changed. But in the first case, if you have only one node, so both the pointers will be pointing the same. But if I'm inserting the next node, so we will insert at the rear at the back side, so the back side will be moved while the front will be remain at the first node. The front end pointer will be with the first node, and if I am inserting a new node, so the back end pointer will be the second node. the first front end pointer will be changed if I'm deleting, if I use the delete function. So coming to the delete function, the deq underscore delete function is that if int x is equal to front end data, as if for deletion you have to assign the front end to the data, and I am creating a p pointer which is assigned to the, as you have to create a temporary pointer for the front end because we have to delete that pointer. Then you have to assign a pointer to the front end, and then the front end will be assigned the next pointer, and then you can delete the p pointer and then return x, because we have to move the front end pointer. First we will mean like this diagram, this is the front. So if I am deleting this, so first I will assign this another pointer, and I will assign this front to 5, then I will delete 7, and at that case the front will be pointing to 5. So you have to create a temporary pointer for deleting anything, as we have used in the stack and linked list. So for displaying the nodes, you have also created a new pointer which is stem. So you have to assign it to the front end, and then see out the q data is, and it will run while the temp is not equal to null, mean it will display all the nodes for you. It will display all the nodes for you till then when it is null. Mean if I have inserted 2 or 3 nodes, so it will run until the temp come to null. So the temp will give us the get data, the data and the get next, because it will be it will give us the data of the node, and then it will move to the next, and then it will give us the data, and then it will move to the next. Mean if we want to display this, so as it is assigned the front, if I am assign it a temporary node, so displaying this data and move to this, then display this data, move to this, and then display this data and move to this. So the main working of the function is like this. And now coming towards the main, so we have to create an object q with the name of the class q dot in q insertion. So I am inserting 3 elements in 3 nodes in the data is 2 4 6 in the nodes, and then I am displaying the nodes, and then I'm using the node word because we are implementing the queue using the linked list method. And then you will deq deletion, as I have called the deletion function once, so it will only delete one element after deletion. So this display function will first give me the inserted nodes with data, and this display will show me the elements after deleting, as only one element will be deleted because I have called the function once. So the q data is 2 4 6. So the 2 is our first data is the front, and the 6 is our back data. And if we want to delete it, so our front data will be deleted. And if I have called the function twice, so my fourth will be also deleted. As I have called the function once, so only one node is deleted at the front. So this was our implementation of queue. Now the lab task is that you have to write a C++ program to implement the queue using linked list, in which you have to give a user four options, that either he want to in queue or dequeue or display, or the fourth option is exit, if he want to exit by selecting. So this is a description that if by selecting queue, user must be able to insert elements in the queue, dequeue must be used to delete elements from the queue, display will show all the elements, while exit show will terminate the program. So you have to write a four options, you have to give the four options to the user, either he want to in queue or dequeue, mean you can use conditions on it. I hope that you get the concept of a queue, and that how you will implement it in the C++ using linked list. If still you have any problems, so we can discuss it in our interactive session. Thank you, students.